Welcome everyone, and thank you for joining us today with our EAStalk webinar. The presenter today is Andrew Richardson. Andrew is a passionate advocate of sustainable aquaculture as a key food production system globally, and the company he works for shares passion. InnovaFeed is a leader in the new agro-industry, insect farming, with a goal of changing the way we think about the food we eat. Today, he hopes to give us an overview of InnovaFeed and the new industry that is helping to form, as well as look at how insect-derived products can change food production systems. My name is Anna Viskovic, and today I will moderate the session. The webinar will last for 45 minutes, with 30 minutes of presentation time and 15 minutes for questions and answers. After Andrew presents his presentation, you can be unmuted, and all the questions you have for him can be asked directly. Dear Andrew, many thanks for joining us today and for giving a presentation on really important topic for the future perspective of the aquaculture. Please feel free to start the presenting your work.
Thank you very much, Anna, for that introduction. And thank you to EAStalk for providing this platform for us to discuss these important topics. As Anna mentioned, I work for InnovaFeed, which is a leader in the new agro-industry of insect farming. And today I want to discuss with you that new industry, some of the solutions that it can provide aquaculturists, as well as some of the challenges that it faces. To do this, we'll break the presentation down into 3 discrete sections. The first is a brief overview of the global context of protein production for aquaculture. So this is kind of really the context within which the insect industry exists. The second is to look at how insects can provide part of the scalable solution to meet the demand of the aquaculture industry. And the third is an overview of what it's like to be an insect farmer, and I'm hoping you'll all find this a really interesting and unique aspect of the presentation. It discusses how we go from the academic theory of insect cultivation for aquafeeds to making it a commercial reality. So first, a brief overview of protein production for aquaculture. So I know many of you will have seen slides like this in the past, and many of you may have even presented them. But I think it's important for us to all have the same level of information going in as a baseline. Aquaculture is the fastest growing food production system on the planet, growing at around 4% a year globally. And what's interesting about that growth is that the fed aspect, the fed proportion of aquaculture is growing faster than the non-fed. And what this means is that as the industry is maturing, it's favoring more intensive and more efficient systems of production. And those systems require a nutrient input. All the information on this slide, by the way, is coming from the FAO's SOFIA 2020 document, which I'm sure is a Bible for many, and if you haven't read it, you absolutely should. What we don't see, however, to match that kind of 4% yearly growth of the aquaculture industry globally, is the traditional protein sources also growing at that same rate. If you look at maybe the most traditional protein source, at least for carnivorous fin fish, which is predominantly raised within Europe, the most traditional protein source would be fish meal. And actually what you see in the case of fish meal is a general negative trend rather than an increasing one. So that in 1994 there's about 30 million tons available fish meal on the market, and by 2018 that had actually dropped to 18 million tons. Indeed, actually, the industry bottomed out at 14 million tons available in 2014. This was due to the El Niño event causing a dip in the Peruvian anchoveta. And this has really kind of had 2 impacts. The first is that as the demand increases and the supply drops, you see a price increase, which is what that graph on the bottom right documents. And with the price increase and the reducing supply, the second impact is that you see aquafeeds producers putting a lower and lower inclusion rate of these marine origin ingredients in their feeds. For instance, it's not exceptional to see an Atlantic salmon grower diet have less than 10% marine origin ingredients. There are obviously exceptions to this rule depending on the product. And a big example of an exception might be the larvae rouge in France, where at least 40% of the diets have to be from a marine origin. So there are examples of exceptions. And whilst technologies such as post-processing, which accounts for over 50% of the production of fish meal in Europe, ensure with things like increasing traceability and MSC certifications, the sustainable and sustained supply of fish meal to the industry, there just simply isn't enough. So traditionally, aquaculturists have long adopted the inclusion of vegetable proteins from different sources as protein alternatives to those marine ingredients. These kind of come with two discrete challenges. One, which is perhaps more zootechnical and performance-based, which is the dietary challenge of including a vegetable terrestrial protein source in a carnivorous marine diet, such as, for instance, the salmon. The challenges are really centered around when it's used poorly, you can include anti-nutritional factors, non-soluble polysaccharides. This can cause things like enteritis, gut morphology changes. In the worst cases, it can lead to some welfare or growth performance problems. Also important to point out that these challenges are all species specific, and even within salmonids there's varying vulnerabilities, so it's always important to have a really good understanding of the fish that you're raising. The second form of challenge is a much more recent challenge in the form of increasingly educated consumers demanding increased sustainability and traceability in the supply chains of their feeds. This is especially visible with challenges such as deforestation in the Amazon, these sorts of things. And I've got on the right there 3 stories from the media, 2 from Undercurrent and 1 actually directly from Maui's blog, which describe ways in which aquaculturists are really leading a charge in promoting sustainable supply chains, specifically around vegetable proteins, and in this case, soy. So Maui has committed to a fully deforestation-free supply chain by 2021. The challenges there are things like increasing the level of auditing of both their own value chain but also their suppliers. Grieg, Nutrico, and Tesco, interesting that Tesco is customer-facing there, it's really exciting, have combined for a soy funding initiative to raise the sustainability of the ingredients. And then finally, according to Undercurrent News, Ala Aqua is actually phasing out South American soybeans. So the challenge they're incurring there is reducing the number of suppliers they'll have to choose from. And so all of those responses are to that second challenge, which is the sustainability of the production of those vegetable proteins. And so how can insects form part of the solution along with other novel ingredients to meet that demand and that deficit created by both the growth in the aquaculture industry, which we've discussed, and the lack of growth in the traditional protein sources that we would maybe use? Well, insects have this incredible ability to recycle biomass into high-quality nutrients for plants and animals, although here we're specifically talking about aquaculture. And this makes them uniquely farmable. So how do they do that? Well, insects consume low-value products, and I want to be quite specific. When I'm talking about low value here, I mean 2 things. The first is that they're not fiscally expensive to get hold of, being from traditionally maybe co-product streams or even waste streams. The second is that they're not very nutrient-dense products that these insects are consuming. And this means that they're able to bioconcentrate that disparate nutrients within themselves. They also have a very favorable amino acid profile. So they take that nutrient, they transform it into something more bioavailable for aquaculturists to use, and they also concentrate it. Insects consume very low levels of resources throughout the farming process also. They can be farmed vertically and in small spaces, and makes them very efficient. They build biomass very quickly and have a very quick growth rate, so favorable FCRs, SGRs. They have a short life cycle, which means they can be produced all year round and processed all year round. They can be raised as part of a fully circular process, which, with a bit of effort, can reduce the impact of their production. And also their production is both scalable and local. And I'll touch on what I mean by that in a second. I thought it would also be interesting to look at how the insect agro industry aligns with modern policy goals. These are the UN sustainability goals we've got on the right here, and insects fall into at least 6, conservatively 6 of those sustainable development goals. There's certainly arguments that it could be made to fit into more. A lot of those sustainability goals focus on things like recycling, upcycling, conserving resources, conserving space, providing new food streams, and increasing levels of infrastructure, job opportunities, and the new agro-industry really is involved in all of those different aspects. So insect farming was really born within Europe in 2017 when it was legislated that, whether the legislation changed to allow processed animal proteins from some insects to be included within Aquafeed's diets. And indeed, actually, you can include other animal ingredients in a host of different animal feeds. So the insect fats and live insects can be used across a more broad range of products. The insect protein is only currently allowed to be used within aquafeeds or within pet food, although we are expecting a change in the legislation in Europe fairly soon. Insects are subject to the EU feed ban, and this means that they can only be fed certain feed ingredients, indeed from 2 discrete categories. The first is vegetable substrates that have met a standard quality and traceability set of metrics, and the second is unprocessed form of foodstuffs, specifically within dairy and eggs, that have also met certain quality, traceability, standardized metrics for measuring quality. So what this means is that in the literature or in articles you might hear it described that insects are going to change the way we think about household waste streams or restaurant waste streams, maybe even kind of effluent streams. But actually within Europe currently this is not the case, and we have to use very specific ingredients to feed our insects. But this is actually an advantage for the European insect industry, because by feeding high quality, standard and fully traceable ingredients to our insects, we ensure that our insect products are also standardized, high quality and fully traceable for our clients. Currently, within Europe, you can farm 7 different species of insects. 2 of them are really maybe more commercially interesting for use within animal feed, although there are others being explored. The black soldier fly larvae, Hermetia illucens, which is the insect that InnovaFeed farms, the one we'll be deep diving a little bit more on today. But the other one that has some commercial interest within Europe is the mealworm Tenebrio molitor. So on this slide, what I've done is I've built a brief biological profile of the black soldier fly, maybe for those of you who aren't so acquainted with it, and why it's such a great candidate for modern farming. The black soldier fly is originally from South America, but since its introduction really to the world in the 20th century is considered a cosmopolitan species. This means that it can be found in the Americas, where it's from, but also within Europe and in Asia. And this means that it's a non-invasive species. From egg to adult takes around 35 days. The adult stage living for an average between another 5 to 10 days, so it's got a relatively short life cycle. The adults don't require food to complete their reproductive cycle, and this makes them very low maintenance when they're in that stage of life. There are currently no known pathogens specific to the black soldier fly. It doesn't spread pathogens, and there's no cannibalistic behaviors exhibited by the organism. This makes it ideal for farming in an intensive system. The larvae, which, to be clear, are the product that we are really doing this process to farm for, have a high crude protein content and a high oil content. So they're those ideal bioconcentrators that I was talking about earlier. And black soldier fly larvae have an essential amino acid profile very similar to that of fish meal, making them uniquely applicable for aquafeeds purposes. On the right here, we've got two pictures. I'm sure you've guessed, but the larvae in the background is a black soldier fly larvae, whilst in the foreground we have one of the adults looking, I think, quite cute. So when we look at the black soldier fly larvae protein, both its general composition and more specifically the amino acid profile, we see that it's very similar to fish meal. And this means that it's quite an easy ingredient to fit into those complex compound diets used within the European aquaculture industry as a replacement for fish meal. You see that the protein content is able to get up to that 60 to 65% category, matching the high quality fish meal, but also it has similar levels of lipids, humidity, ash, these sorts of things. More specifically, when we look at the essential amino acid profile, you see where there is a spike in fish meal, typically you'll see a spike in the black soldier fly larvae meal as well. And when we compare it, as they did in 2014, Barrasso et al., with other insect meals from various different life stages of the insect, they compared those insect meals with both fish meal and soy meal. You can see that the Hermetia illucens larvae actually grouped with fish meal, much closer than soy meal, which is actually in the complete other branch of the tree. You can see that it really is a very applicable ingredient to replace fish meal. And indeed, based off this, we have several research scales that have been explored, both kind of smaller and industrial scales, which has kind of built a body of evidence for their applicability of these ingredients within aquafeeds. So InnovaFeed has done several trials testing up to 100% replacement of fish meal in salmonids, no negative effects on any growth metrics. In shrimp, we've actually seen positive effects of inclusion of black soldier fly larvae meal, indeed actually both on the growth performance but on disease resistance, and you're starting to see this mirrored now in the literature as well. We've explored Mediterranean species such as sea bass and sea bream and haven't recorded any negative effects. And then finally, in catfish, we've showed positive trends for growth metrics with inclusion of the black soldier fly larvae meals. I can also share with you one of the trials that we did with salmonids. I thought it would be interesting for you to see some data. We did a trial with 13,000 trout, so that's 6,500 trout in each diet group. One diet was fed a traditional, conventional commercial feed, and the other diet was replacing 50% of the fish meal in that conventional diet with Proteinova, which is our black soldier fly larvae meal product. And you can see sort of from day one, there's a performance boost with up to 14% improvement in FCR being recorded across those trout. Finally, also definitely something to consider when you're trying to think about revolutionizing the way we think about what we feed our animals. You have to think about how consumers are going to feel about that and the way they internalize that. And what you see when you do consumer surveys is that consumers, at least when they are looking at products such as meat and seafood, is that they consider sustainability and naturality very high on the list of decision factors. And those two are important because when you explore and ask the consumers what they think about insects in terms of those two features, you'll see that most consider insects to be more natural, and 40% consider it to be more sustainable than alternative feed ingredients. So this really removes a lot of those barriers for consumer acceptance. And indeed, actually, when you ask consumers about whether they would buy trout fed with insects over trout fed with traditional commercial feeds, you'll see that actually 90% of people would rather buy the trout with insects in the diet. The understanding this is quite clear, really. When you think about how you'd go fishing for trout, you think about fly fishing. There's a clear idea of the naturality of insects as part of a trout diet. And that really opens the door for the use of insects within our seafood value chains. Is a really interesting and exciting area. So onto the final couple slides of this presentation. I want to give you an overview of what it's like to be an insect farmer, to give you a bit of a peek behind the curtain. So being an insect farmer is a little bit different to being an aquaculturist, because we have to have this broad range of expertise. We are the feed formulators. We are the experts that monitor growth performance. We are the broodstock managers, but we're also the processors and the transformers who transform our products. So what this looks like in reality is we take co-products from the agricultural industry, so that fits into that vegetable substrates category we discussed earlier. And with them, we formulate a proprietary substrate which acts as both the nutrient source for our insects, but also as the environment within which our insects exist. So that foodstuff has to be not only nutritionally applicable to the insect's requirements for a healthy life, but it also has to be an environment within which they can exist and perform their natural behaviors. So the insects are raised within that substrate. We keep less than 1% of them and raise them up to adulthood. When they're in adulthood, they breed naturally in a chemical-free process. The eggs from that breeding are then injected into the next batch of substrate, which completes the life cycle and fulfills the breeding process. When the larvae are at a size and weight required, we put them through processing, and from that we're able to secure two products. The first is insect oil, which is used within poultry and swine value chains. The insect oil is high in lauric acid, which is mildly antibacterial. The insect protein, which we're really discussing today, is used mainly within aquaculture value chains. There is a third product, although it doesn't come directly from the larvae themselves, but it's actually the insect droppings. We call this frass. It's a natural organic fertilizer. That fertilizer is spread on fields. The fields which supply the agro industry with the products they require to produce the co-products that we require to make our proprietary substrate. And in this way, with a bit of effort, you're able to create a fully circular production process and reduce the level of impact that you have by producing your products. So, InnovaFeed has two facilities, and I thought it would be interesting to walk you through them. The first was founded in 2017, or started a production in 2017, rather. That's that important date because it's when you can start to see aqua feeds, including insect meal products. The pilot facility has 4,000 meters squared of vertical farming area. And with the insects from this facility, we've been able to kickstart a couple value chains. The first was insect-fed trout, and I actually showed you some of those kind of commercial survey results from that. The insect-fed trout was really interesting because we had the opportunity to market directly to consumers that the trout they were buying had been fed insects, and we were able to do that by partnering with Auchan, which is a retailer in France. In 2018, we also announced a commercial partnership with Cargill EWOS and have been working with them since then. 2020, we were able to launch the first insect-fed poultry in the world, again able to market directly to consumers the inclusion of insect products within the poultry feed. Although this was insect oil, as we previously discussed, you can't currently use the insect protein in poultry diets. And hopefully soon we want to announce the first insect-fed swine in the world as well. Before I move on to the next slide, which is a look at the world's largest insect factory, I want to bring your attention to the area of cleared plexiglass on the roof of our pilot facility in Guzuko. You can see the long line of kind of windows on the top of the roof. This is where we keep the adult flies. And this is because they require natural light as part of their signals for breeding, right? So it's important for the breeding process that they have access to that natural light source. I bring your attention to that because on the bottom left of this slide, you'll see an enormous 2-story greenhouse. And this is where we'll keep the adults for our new production facility in Nel. Nel is, to date, the largest insect factory on the planet, and we hope to have it up and running with insects inside by the end of 2020. The insects that live inside that greenhouse area, don't worry, they're not roaming free. They'll be in kind of discrete cages. A fully automated system will supply 20,000 eggs every second, which will be injected into over 50 tons of substrate every hour, that proprietary substrate that we make up. This means that we'll have 1.5 billion larvae growing on this facility at any one time. By being so large, we're able to partner with really large players, both upstream and downstream. The InnovaFeed facility at Nel is co-located actually with 2 players just outside of shot in these photos. The first is Tereus, which is a starch manufacturer, and from them we'll be able to secure the products that we require to make that substrate. And we'll actually get that substrate piped to us through a direct pipeline. This means that we won't have to use any lorries to get a hold of that substrate. It also means that they won't have to process them, so it's environmentally sound not only in terms of the logistics, but also in terms of increasing the sustainability of Tereus' processes. The second partnership is with Cogeban, which is a waste biomass turbine, a waste wood biomass turbine, sorry. By partnering with them, we're able to ensure that all of the electricity used on the Nel site is from a renewable energy source. But more than this, actually, up to 70% of the energy used at Nel will be waste energy, which we will capture from Cogeban's heat exhausts. By attaching a hydro condenser to those heat exhausts, we're able to capture fatal energy that was previously wasted into the atmosphere. So in terms of how the solution can be scalable and local, this is an idea of InnovaFeed's plan to roll out globally. I'm sure that a lot of the other novel ingredient suppliers will also have similar plans. The idea is to have multiple facilities at large scale across the world supplying insect protein to meet local demand from local animal feeds industries. So today I wanted to provide you with an insight into the new agro industry, some of the solutions it can provide aquaculturists, as well as some of the challenges it faces. I hope that I provided you an insight into the context within which the industry operates, given you a brief overview of how insects are appropriate to modern farming, their alignment with modern policy goals such as the UN Sustainable Development Goals, the legislative status, at least within the EU, and some of the challenges that it faces in that respect, the biological profile of the black soldier fly, why it's so applicable to modern farming methods, the black soldier fly larvae's nutritional profile and its applicability to aquafeeds, and then finally a look at commercial insect farming operations and a bit of a peek behind the curtain on what we do on a day-to-day basis. So thank you very much for listening. Thank you very much, EAStalk, for giving me the platform. And I think we'll have some questions next.
Thank you, Andrew, very much for giving excellent presentation. We have a lot of questions for you, so I hope you're ready to give an answer to all of them.
Yeah,
So the first one, I will start with Onas. Onas is asking, are dried whole insects transformed into powder allowed for fish and pet food?
Yes, so I think what he's talking about there is dried, defatted insects. And so, yes, this is currently allowed within the EU legislation for aquafeeds, absolutely. Aquafeeds and pet food, yes.
Thank you. The next question we have is from Risha. Have trials been done to use insect meal to grow shrimp and prawns?
Yeah, so trials have been done. I think there's now a couple of papers in the literature, so you can go and read some papers. But InnovaFeed has also conducted a series of trials with shrimp. We're super excited about the results. I unfortunately can't share them with you, but as I discussed during the webinar, there's a performance boost to both growth and disease resistance as well, and that's been mirrored in the literature.
Okay, thank you. Another question, Teresa is asking, sea bass, sea bream, and catfish trials, were they done with 100% replacement of insect feed?
So I don't have numbers with me to hand on the kind of the Mediterranean species. I think with the catfish, I think it was more than 100% of the fish meal, because the catfish is a fairly omnivorous species, and so it's not difficult to replace more than 100% within the diets of the fish meal in that case. But I don't have the numbers for the Mediterranean species to hand.
Okay, thank you. Rahim is asking, how is the digestibility of the feed containing insects in sea bass aquaculture?
So in terms of the digestibility, what we commonly see with black soldier fly larvae protein is that it is comparable to fish meal in terms of digestibility, not only in terms of the protein, but also the energy as well. The fats in the insect are low chain. They have a low number of I can't remember the term, sorry. But that makes them extremely digestible and very bioavailable for the fish. So the energy is very digestible as well as the protein.
Thank you. Marco is asking, what do you think about broodstock fish feeding with the insect meal products? Have you taken some trials about this?
So broodstock are a really interesting area to explore in aquafeeds, because it's definitely an area where you see the use of these super premium products. And I think with broodstock, the important thing to understand is that you're really tailoring the food to the species. So it's about exploring the unique applicability of each ingredient to that species specifically. So where you see outstanding performance with insect meals, of course, there's an applicability in broodstock as well.
Thank you. The next one is from Yang Xian. What is the bottleneck of decreasing the price of larvae meal so that is the most competitive in the raw ingredient market?
Okay. Well, the answer there is scale, right? And so it's all about being able to produce enough that you can take advantages of economies of scale. And that's why that last slide where I discussed the rollout globally is really important, not only as a proof of concept for novel feed ingredients and insects, but also so that we can be at a scale large enough to really have an impact on the sustainability of the industry.
Thank you. Another one is again from Aberdahim. Are the enzymes used in the insect-based fish feed to improve the digestibility?
So I'm not a feed formulator. I know that enzymes are used within aquafeeds diets to increase the digestibility of vegetable proteins, for instance. It's not my understanding that these are used to increase the digestibility of insect meals currently. But I mean, I think that area of innovation in the aquafeeds realm is super interesting. Absolutely.
Thank you. Let me just say something to participants. We do have a lot of questions, but in case you would like to talk directly with Andrew, you just need to write me a message that I can unmute your microphone. I will go now with Tim. Tim said, great talk, Andrew. You mentioned that these black soldier flies don't carry any known pathogens. Presumably, some get sick. Do you know if any mass mortalities during larval culturing or any other events leading to inconsistent yields?
Yeah, so one of the interesting things about black soldier fly larvae is that actually currently there haven't been any outbreaks of disease or mass mortality recorded at all. Indeed, when I say there's no known pathogens, what I mean is that there are no known pathogens that cause mass mortality of the sorts that you're describing for black soldier fly.
Thank you. Also, Tim is asking, what sort of steps are being taken to improve health genetics of the insect being cultured?
If we're talking about sort of the broodstock genetics, which I think the question is centered around, insects have a very short life cycle, and this makes them quite interesting in terms of the genetic capabilities. If you talk about a generation-on-generation improvement, then clearly if your generations are cycling quickly, you can get that improvement more rapidly. And that's certainly a technology that, as the industry matures, will become more and more exciting to look at. We currently do have a broodstock planning program involved, but as yet we're not able to take full advantage of all of the genetic tools out there, but we are excited to explore that in the future.
Thank you, Andrew. The next one we have is from Katrina Lang. I have a question about black soldier flies farming. What are the downsides of the things you strictly have to consider when farming black soldier flies? How does the material feed to black soldier flies affect the amino acid profile?
Okay, so something to consider when farming insects is that they're quite sensitive to temperature. Our insects like a temperature range between sort of 28 to 32 degrees, I believe. And falling outside of that temperature range can drastically affect performance. If we talk about an all-year-round supply, and you imagine northern France in winter, I can tell you it's not 30 degrees, and you have to be quite careful with keeping your ventilation and your warmth. So that's an area that does pose a challenge, but it's definitely kind of been surmounted by the engineering side. And then in terms of how the amino acid profile is affected by your feedstuff, fortunately the way I think that kind of proteins are digested and then rebuilt up within organisms, the amino acid profile is not hugely variable. What you do see is the oils are more variable depending on the kind of substrate that you use.
Thank you, Andrew. The next one is from Diego. With the current trend of traceability towards the products we consume, yep, what are the challenges to sell insect feed fish to people who are reluctant to have flies in the food they eat?
So I think that to break the question down into two sections, firstly, because we are buying substrate products which are fully traceable, it means that our products are also fully traceable, and we have a kind of absolute visibility on where products from different batches go, etc. So from our own traceability side, fully secured. In terms of the consumer side of things, there's really two parts to that as well, I suppose. The first is about increasing consumer awareness and education. I think this is really something that aquaculture in general kind of needs to get better at, is communicating with consumers on issues like sustainability and things like this. And the second thing is, I'm not sure how aware consumers are of what is being used as animal feed ingredients. And so by being really vocal about our insects and making consumers comfortable with our insects, I don't think we have much of a challenge in that respect. But yeah, education is always the answer.
Thank you, Andrew. The next one is from Robin. Can salmon fry and fingerling feeds also contain 100% fish meal instead of fish meal, or only in grow out stages? So I guess it's 100% fish meal instead of the insect meal.
So I don't have the report available now, so I don't want to give you any figures that might be wrong, Robin. However, in the pre-smolt stage, when the salmon are living in rivers, such as when they're fry, fingerlings, etc., they're in an environment which is surrounded by insects and insect proteins and insect products. And indeed, we see very high digestibility of insect proteins in salmon smolt.
Thank you. Federico is asking, he also said great presentation. I'd like to ask you if apart from Hermetia, you'd had any experiences with Tenebrium.
So I can honestly say that I don't have much personal experience, so I don't particularly want to comment on the other insect species. I think that there's definitely space in the aqua feeds and in the animal feeds industry for lots of these novel ingredients, of which I'm convinced Hermetia illucens is will provide a key role in the future. But all of these ingredients can be tailored to different areas of both aqua feeds and animal feeds.
Thank you, Andrew. The next one is from Flo. Insects contain cytine. How can it be digested by marine fish species? What is the current status for insect meal for organic aquaculture?
Okay, so there's two questions there. The first is about chitin. Chitin is an interesting compound. It's the most it's the most available compound on the planet, I think, outside of cellulose. I think that's correct. And it is also been shown in various papers and publications to have kind of positive effects on digestibility. It can also stimulate the immune system. So in itself, it has some interesting properties that kind of need to be explored further and understood more. And its digestibility is species specific. So organisms such as shrimp, for instance, which consume their own carapace, etc., it's very digestible. If the natural diet of the animal includes chitin, then they have an ability to digest. And I think there was a second part to the question, which I'm blanking on now. Can you repeat was there a second part?
What is the current status for insect meal for organic aquaculture?
Sure. So there isn't currently a European standard for insects. It's something that's being worked on. To be organic, everything within your value chain has to also be organic, which would mean that it's likely that the substrate we use would have to be organic for us to be able to produce organic insects. That's the visibility I can give on that.
Thank you, Andrew. The next one is from Manon. How sustainable is to farm insects for aquaculture if you could directly use them for human consumption?
Yeah, so again, I think it's a good point, right? Why can't we just use insects to feed humans directly? And I mean, are people eating insects? You know, how applicable are insects to at least European diets? You know, I think that using insects as a bioconcentrator to gain access to a nutrient stream not previously available for aquaculturists, to use within aquaculture, which is like a very low carbon way of producing protein, you know, is the way forward. There are other insect species that might have an interest for direct human consumption, but I think you'd have to see consumer eating patterns change a lot before you start to see kind of like mass production, at least within Europe, for this.
Thank you. The next one is from Nico. In order to sell insect powder, does EU legislation require that it is defeated first? Defatted first, sorry.
No, it's not my understanding that there's an explicit requirement for it to be defatted first. We defat the oil and the protein because separate, those two products bring more value than they do necessarily combined. So the protein is uniquely applicable in certain instances, such as in aquafeeds, whilst the oil has, a real applicability in other streams. What we do have to do is go through a sanitary agreement with kind of certain hygienization steps, but I'm not aware that the splitting of fat and oil is a part of that that's required, no.
Okay, thank you, Andrew. And the thing is that we are already 15 minutes past for the questions, but we still have 5 more questions. Would that be okay for you if we answer on all of these?
Yeah, absolutely. I'm super happy to keep answering questions, but also if people want to reach out to me, they can. We're always excited to work with researchers or, to field questions from people. So, please feel free to reach out to me if we don't get to your question.
Great. The next then is from Maria. What are factors that would help the increase of 100% exchange instead of fish meal? Legal factors, economic founding, political contribution.
I think that there's kind of maybe 2 things. The first is that insect protein is not yet at a scale where what we can say to a aquafeed supplier or a fish farm or whatever is we'll replace 100% of your protein requirements throughout the whole life cycle. So there's a kind of a scale challenge where insect protein is not yet produced at volumes enough to offer that. But that's going to be solved as through a function of the time as the industry matures. And then outside of that, I think really it's about consumers wanting to get hold of the seafood that they perceive to be aligned with what they want from their seafood. So I'm not particularly aware of any sort of political measures that are holding the industry back from doing that. I think that actually insects are very aligned with modern policy goals, as we discussed today.
Thank you. Nicole is asking, have there been any challenges regarding the palatability of insects meal?
No, actually. I'm smiling because I've just recently gotten results back that I can't share with you. But the answer is no in both trout and in salmon.
Great.
Yeah.
Boata is asking, insect protein are a great substitute for fish meal, but fish oil remains as important, if not only source of omega-3 for the aquaculture feed manufacturing sector. Which is the vision of InnovaFeed to overcome this challenge and allow to reduce these products from wild resources?
Sure. So, insect oil is not rich in omega-3s. It is rich in lots of other fatty acids, which are great for animal nutrition, but omega-3s are not included. And InnovaFeed isn't looking to start including them in the insect diets. That would be an inefficient use of that valuable resource. There are, however, other innovative novel ingredients such as algal oil that do tackle that challenge. And this is another reason why we talk about splitting the protein from the oil, right? So the protein can be used to replace fish meals, and the oil is defatted out so that it doesn't replace fish oils in the feeds.
Thank you, Andrew. The next one is from Martin. Thanks for the great talk, Andrew. Are you facing reluctancy of the aquafeed industry due to low amount of insect meal producers? I mean, reluctancy to design products with only 1 or 2 suppliers.
So I think that aquafeeds players are quite involved in the development of the insect industry, and I think they're all communicating with each of the insect players quite a lot, and indeed you are starting to see aquafeeds including insects within the diet. I think scale is another challenge, well, not challenge, but it's something that will be overcome with time. These players produce huge volumes of feed, so to have large inclusion rates, you also need to produce vast volumes of protein. And in a couple of years, and with the advent of the world's largest insect factory, we'll get there shortly.
Great. The next one is from Boata. Insect protein are a great substitute to fish meal, but fish oil still remains an important, if not the only source of omega-3 for the aquaculture feed manufacturing sector. Which is the vision? Okay, sorry, this is the question. Yeah, I already have this question.
Sounds familiar.
Yes.
Yeah.
Then we have the last question for today.
Okay.
It is from Harish. Harish is asking, have you ever considered to culture Hermetia larvae based on agro-industry waste? For example, palm kernel meal from palm oil processing. It probably can increase the oil lipid content from the larvae.
Yeah, so when we discussed an industrial rollout step of insect production globally, we mentioned having insect factories and insect production facilities in different areas. And when you're in different areas, the food that you'll use to raise those insects will be from the local region as well, right? It's an important part of sustainability and using what's around you and all of that upcycling. When you consider areas such as Southeast Asia, which have very large and very kind of busy aquaculture industries, they also have very large palm and industries, and there are exactly opportunities to take advantage of those industries to upcycle the co-products from those industries, increasing the sustainability of them and providing a food source for our insects. So yes, absolutely, it's a part of expanding outside of Europe. It wouldn't be super interesting to import those products to Europe to use here, but when we go there, absolutely.
Thank you, Andrew. I would like to thank you all for participating in one of our most successful webinars. Thank you, Andrew, for accepting our invitation, and also thank you to InnovaFeed for presenting the work you do with the insects. I would like to say that our next webinar will be on October 6th with Dr. Konstantinos Milonas. Dr. Milonas will give a presentation on preparing a manuscript for scientific publishing. I would like to share with you, in case you would like to propose a webinar or a topic, you can send me an email on anna@aquaeas.eu. And thank you very much, Andrew. I can see that the comments in the chat box are really great, and that you did on the end amazing presentation.
Thank you very much. And again, if anyone wants to reach out to myself or someone from the InnovaFeed team to discuss either opportunities, commercial or otherwise, then please reach out to us. We're nice people.
Please reach Andrew, and I wish you all the best with the work you do.
Thank you very much, Anna.
Yes.
Thank you again.
Thank you, Andrew.
Okay. Bye bye.